This is lesson 5 of unit 13. In this lesson we'll talk about properties of solutions, also called colligative properties. This is a fancy word. It just means, comes from the word like collegiate or colleagues, which means there's a lot of them together, and together, mixed together, they give some sort of property. And so pure substances, remember, like if you have just pure water versus if you have a salt water solution, NaCl, have different properties, even though most of this is also water. So we're going to talk about these properties of these solutions. So the first property comes with this question: how can you make an egg float in water? If you ever tried it, regular eggs will actually sink in fresh water, but if you put them in salt water, they'll actually float. And this is because a solution has a higher density than the regular solvent. And this is very logical, because if you have yourself a solution, you've added mass to your water, and now you have a higher amount of mass for the same amount of volume, and your density is greater. And that egg, which still has the same density as before, now feels lighter compared to the water. So the idea here is this, that the density of a solution increases as solute is added to it. Here is a gentleman reading a newspaper, and this is actually the Dead Sea in the Middle East. And the Dead Sea has essentially salts flowing into it all the time, and it's so dense that you don't even have to paddle or try to keep yourself afloat. It'll do it automatically. It's so dense. So by comparison, your density is really low in the Dead Sea, and it's called dead because it's so salty, not much lives in it. You can also do this little experiment where this is called the rainbow tube experiment. All you need is food coloring, salt, and water. What you do is you make different salt concentrations, and you layer, and then you put food coloring in them, and you layer them. So the most dense would be down here, and then slightly less dense, and this rainbow will actually very, very slowly mix together over a number of days. But it'll keep it together in this rainbow fashion for a long while until it mixes. So that's density and solutions. The other, or the next colligative property comes with this question: what happens to the boiling point as you add salt to water? So if you have two solutions, one is a regular solution, and the second solution has salt in it. It's a salty water solution. The question is, will this solution boil at 100, or above 100, or below 100? Now, if you think about it, because the particles in the solution are now bonded with water, now the water molecules can't escape as easily. It's tougher for them to escape because now the salt particles are holding the water molecules together. This is because when a solution formed, new bonds were created. And so it's going to take more energy to boil the water away, to release those water molecules. So actually it'll boil at 102 degrees Celsius, maybe 103, 105. It doesn't go too much higher. It won't go to like 150. But the boiling point actually goes up. And what happens to the freezing point? The freezing point actually goes down. And we'll say this here in a minute. So the freezing point goes down, the point of freezing goes down, the point of boiling goes up, is the idea. And what you see here is the reason why we throw salt on ice in the wintertime and the ice melts is because when you throw salt on it, you create a solution. And that solution now has a lower boiling point. So instead of freezing at, lower freezing point. Instead of freezing at 0, it may now freeze at negative 15 degrees Celsius. Well, if it is 10 degrees Celsius outside, then at negative 15, it should remain a liquid, and that's why it melts. So it essentially lowers the freezing point of water, and the water is no longer frozen when you throw salt on it. So this idea of lowering the freezing point is the concept behind throwing salt on icy roads. And along with that, here it says adding a solute to a pure substance raises the boiling point and lowers the freezing point. So this is just a overview of the last slide. And it also lowers the vapor pressure. Remember, so here's are the pictures essentially. You have a pure solvent, so we'll say this is just regular water. The regular water, if you close the container, has a certain vapor pressure. This is the pressure due to just the vapor of that liquid. Now when you add a solute to it, now you have salt in water. We'll say you have NaCl, aqueous. Now those salt particles, which are represented by these black spheres, hold the water molecules together and don't let them escape as easily, and less of them get into the gas phase. So the vapor pressure has lowered. The boiling point is now higher, because if you want to get the same amount up into the gas phase, you have to add more heat. The freezing point is now lower, so because these salt particles don't allow the water molecules to mix with each other or come together and freeze with one another, they get in the way, so the freezing point is lowered. So this is universal no matter what type of solute you use. So if you use sugar versus if you use salt, the effect is similar. All right, and the phase diagram, which we've seen before in chapter 12, looks like this. So here it says the solvent boiling point. This light purple line, you can say, is the solvent boiling point, again, your water. And then the blue line is the solution boiling point and the solution freezing point. So what happens is the liquid range, remember this is the liquid range of the phase diagram, the liquid range expands. So now water is a liquid at a higher temperature, it's a liquid at a lower temperature. And that's the whole idea. More of the temperature range is now in the liquid phase. And that's what happens to a solution. That means your boiling point will be higher, so versus here, it'll be here. The freezing point will be lower. So instead of here, it'll be here. That's the idea. Now, we're going to make this statement. We're going to say that salt will actually lower the freezing point of a solution more than sugar. Both salt and sugar lower the freezing point, but salt does it better. And the question is why? And the answer is because salt is an electrolyte. We defined electrolytes are substances which conduct electricity, but they conduct electricity because they split up. The fancy word is dissociate. Dissociate in solution. And that's what you see here. In this case, salt, if you throw it into water, breaks up into sodium and chlorine. So you get 2 times as much dissolved, as much solute, essentially. And if you have 2 times as much solute, then you have a bigger effect on the freezing point, on the boiling point, on the vapor pressure. In this case, sugar, this is sugar, does not dissociate. It dissolves, it becomes aqueous, but it does not break apart. It still stays together, stays sugar, so it doesn't provide you as much solute. And that's the idea, and that is why. And then furthermore, the more ions you have in solution, the lower the freezing point. So different salts can produce different effects. A regular sodium chloride will produce 2 ions. It breaks up into sodium and chlorine, but calcium chloride will actually produce 3 ions. And you see here calcium chloride giving you 2, remember there's a 1 here, you get 3 moles on the right side, you have only 1 mole on the left side. With sodium chloride you have 1 mole on the left side, but 2 moles on the right side. So calcium chloride is better. In fact, whenever you buy a de-icer in the wintertime, it'll often have calcium chloride in it, or sometimes they'll put magnesium chloride in it. And it usually says this has superb melting ability because of these salts. Okay, so these are colligative properties. The properties that we've looked at before for regular solvents, and now the same properties, but for solutions. So this concludes for us lesson 5 of unit 13.